Hello, my dear students. Today we are going to discuss about the velocity of the piston. Now we'll start from the dynamic forces are associated with the reciprocating masses. As we know that the dynamic forces are always present when the machines operate. In the situation where the dynamic forces are dominant, the dynamic analysis has to be carried out. For this, we will start from the velocity of the piston. So we have to analyze the velocity of the piston with the help of the crank and connecting rod of a reciprocating steam engine. So this is the diagram of crank and connecting rod of the steam engine. So here you can see that the motion of the steam engine or crank and connecting rod of the steam engine. In this, you can see here, this is the crank and this is the length of connecting rod, and here you can see the velocity of the piston. So we have to carry out this velocity of the piston x. These are the terms: L, the length of the connecting rod between the centers, R, radius of the crank and or crank pin circle. Similarly, N is the ratio of the length or connecting rod to the radius of the crank, that is L by R. So here you can see that from the geometry, displacement of the piston x is equals to this P dash and this P, the P dash, and the value of the P dash is calculated from this diagram is O P dash minus O P. So now this OP is calculated or measured from this OP, that means this O and P. So this OP is equals to C PQ plus QO, and this OP dash, that is equals to P dash C dash plus C dash O. This P dash Q dash, that is equals to L, and C dash O dash, that is equals to R. So with the help of this equation, we will have the value of x. So now this is the equation 1, that is the x displacement of the piston. R that is equals to 1 minus k cos theta plus n 1 minus k cos phi. So from the triangle CPQ and CQO, this is the CPQ and CQO. So with the help of these two triangles, we will have the value of L cos phi equals to R sin theta. That is L by R is equals to sin theta upon sin phi, which is, that is L by R is equals to N. N is the ratio of the length of the connecting rod to the crank radius. Or we can say, we can written as sin phi is equals to sin theta upon N. So we know that the sin square phi plus cos square phi, that is equals to 1, or we can say that the cos phi is equals to 1 minus k sin square phi raised to power 1 by 2. So from the triangle, this triangle, we can calculate the value of sin phi and substitute in this equation, and the expanding this equation by the binomial theorem, and we will get the value of cos phi is equals to this. So this is the value of 1 minus k cos phi in substituting in the equation number 1, and we will have the value of displacement of the piston, and the differentiating this equation with respect to theta to calculate the d theta upon dx. And now finally we have to calculate the velocity of the piston. So the velocity of the piston, that is equals to displacement with respect to time, the dx upon dt, and it is also can be written as the dx upon d theta into d theta upon dt. This d theta upon dt, that is equals to velocity of the angular velocity of the piston, that is omega. This is omega, and we have already calculated the value of dx upon d theta in the previous equation, and substitute this value in this equation, velocity of the piston. And now the velocity of the piston Vp, that is equals to r omega sin theta plus sin 2 theta upon n. So this is the final equation of velocity of the piston. Thank you.